Welcome to my fifth video on Waves and Thermodynamics, or if you're watching my playlist, this is my video that continues on from reflection and refraction. I had to split the syllabus dot point into two, so I'm just going to be discussing diffraction and wave superposition today. So diffraction is a spreading out of waves as they pass through an aperture, a hole basically, or around objects. Okay, so very small aperture sizes, the vast majority of the wave is blocked, and for very large, the waves pass through the obstacle without any significant diffraction that is only largely at the edges. Okay, so you can see that with the two diagrams there on this slide. So let's have a look at a question here that you may be asked in class. So the diagram below P and Q show two different proposals made by scientists to explain what would happen when the light passed through an edge of a barrier. One of them proposed that light was comprised of particles and the other had a wave nature. Which diagram represents which proposal? Justify your answer. So you may have learnt this previously, that light or the duality of light, scientists were confused whether it was a particle or wave, and Einstein said it comprised of both. And you've got here two different scenarios on what puzzled scientists back 130 years ago. So let's have a look. Not just 130 years ago, over time. So let's have a look here at what would your answer be. So P represents the particle nature of light because it was believed that particles would not form diffraction patterns and would simply be blocked or travel on without a change in direction. And you can see that that doesn't diffract around the barrier. And Q represents the wave proposal because diffraction is occurring basically. Now let's have a look at wave superposition. Now this looks at where waves combine. So this refers to the physical addition of two or more waves. Okay, so let's have a look here at interference. So when the waves interfere with one another. This is the interaction of two pulses as they cross each other, and that can be broken down into destructive interference and constructive interference. And as the name suggests, destructive just means that you get a flat line, and constructive just means that you get the addition of waves, which increases the amplitude. Okay, now let's have a look here at two waves in phase will combine to form a larger amplitude. Two waves at 180 degrees out of phase would be just a flat line and they cancel each other out. And if they are out of phase completely without any kind of regularity, you're going to get a resultant such as the green diagram there, where you need to add specific waves in the locations of that diagram. Now here's a series of questions where you're going to have to add the two waves together to look at superposition. It's extremely difficult to do this, and you need graph paper to do this and to line up the waves in the correct order. However, I've put this in my video for you to have a go, and I'm going to answer it in a moment. So if you'd like the opportunity to pause it now. Okay, now let's have a look at those answers. And you can see that answer A and B flatline because those waves cancel each other out. And then you've got C and D add together, and you can see that by the answers there. Now E also looks like the answers in C and D, but they're off slightly. And F is a superimposed where you have a regular pattern compared to C, D, and E. Now G looks really regular with a larger amplitude, and F you've got a decreasing wavelength. Now it's extremely difficult to do this, and I've just inserted in my video for you to get an idea on what you may enter in class, or what you might be looking at in the future in the physics course. Now we'll be doing this in class, my students, but I wanted to put this in a video so you can kind of get an idea before we tackle these problems in class. If you're new to my channel or if you're a returning visitor, please subscribe if you already haven't, and watch my module 1 and 2 already on kinematics and dynamics. Thank you for your support.